Uses and importance of electric quadrupole moment of the nucleus. Before this video, I told you about the expression or the formula derivation for the electric quadrupole moment of the nucleus. There I told you about the shape and the distribution of the charge of the nucleus in the nucleus. Now here we will have that how this is important physical quantity in the nuclear physics. First is that it measures the departure of nucleus from the spherical symmetry. It means that all the nuclei are not spherical in shape, but they are elongated. That means they may be prolate or oblate type. It gives the information about the nuclear structure and the nuclear forces. Nuclear structure, as I told you, whether this is spherical, oblate or prolate. Nuclear forces which are responsible for the stability of the nucleus. So this is a very important factor which is responsible for the stability of the nucleus, that we study the nuclear forces. So this quadrupole moment also tells you about the nature of nuclear forces. The study of nuclear quadrupole moment with Z or N shows that Q generally increases with the increasing number of Z or N, but it is 0 for magic number nuclei, in which the Z or N or both are equal to 2, 8, 20, 50, 82, 126, etc. It means that the quadrupole moment is 0 for the magic number nuclei. Now this quadrupole moment shows that most of the nuclei have elongated form for which Q is not equal to 0. As I have told you earlier that this Q is equal to 0 when the nucleus is located in the isotropic space. That means when this have the spherical charge distribution. But most of the nuclei have Q not equal to 0, so they are not spherical in shape, but they are elongated form. Nuclei with Q equal to positive shows that there is coupling between the axis of nucleus and the spin, and maximum nuclear forces are responsible for the stable nuclei. For example, deuterium. In deuterium there are two nucleons, one proton and one neutron. Now the spin of these two nucleons is parallel, or this is along the axis of the deuteron. Nuclei with Q equal to positive, there are so many examples: deuterium, beryllium, nitrogen 714, neon 1021, etc. Quadrupole moment shows that nuclear forces are non-central. Since quadrupole moment is not 0 for most of the nuclei, it means that nuclear forces are non-central. It means that they not only depend upon the distance between the two nucleons, but they also depend upon the spin of the nucleons. As I have shown here, when the spin of two nucleons are parallel, then the nuclear force is maximum. When the spin is anti-parallel, the nuclear force is weak. So this have a very good information that nuclear forces are spin dependent also. It is used to study whether a particular nucleus will show nuclear magnetic resonance or not. This is a phenomenon, nuclear magnetic resonance. As you know about the resonance, in the 11th class this is taught in the chapter of the waves, that when the two frequencies are equal, then resonance takes place. Here also, since the nuclear have the motion, that is the spin motion, so because of that it has its own frequency, and if the applied magnetic field which is which is changing with the time, so that it has the frequency, then the frequency of the applied magnetic field and that the frequency of the nucleus, they are equal, then resonance takes place. This is called nuclear magnetic resonance. So this quadrupole moment also tells us whether the nucleus will show the nuclear magnetic resonance or not. Magic number nuclei and even nuclei do not show nuclear magnetic resonance. For example, carbon 612, oxygen 816, calcium 2040, etc. There are so many nucleus. It can separate and filter the ions of distinct m/z ratio in quadrupole mass analyzer. There is a quadrupole mass analyzer in which we analyze different types of ions. So this study of quadrupole moment also is useful to have the distinct ions with the value of m/z. Nuclei with Q equal to negative, that means the lithium 36, lithium 37, oxygen 817, fluorine 9, 19, etc. have the prolate charge distribution. It means that the most of the stable nuclei are not having this spherical charge distribution. They are elongated form. Thus the quadrupole moment is a very important physical quantity to study many of the physical phenomena, particularly the charge distribution in the nucleus and the nature of the nuclear forces. Thank you.